Hello, my name is Mr. Rogers, and you're watching the video lecture for Section 1-5 in our book here on plate tectonics. And so today, guys, this first page, we have our lesson objectives, and today our big goals are to explain the theory of plate tectonics, and also we want to be able to describe the three types of plate boundaries. Those are our big goals for the day. And so before we get started, we got our good friend back, Arnold Schwarzenegger. He decided to come back and say hi. And anything you want to say, you want to ask?
I want to ask you a bunch of questions, and I want to have them answered immediately.
All right. No problem. I'm happy to play along here. So, what kind of questions do you have for me?
Who are you?
I'm Mr. Rogers. We've met before. So, answering your question, Mr. Rogers.
No.
You sure?
No.
Okay. Well, maybe we'll come back to you later on, but it seems like you kind of got nothing else to say. So we're going to move on. So today, guys, we're talking about plate tectonics. So plate tectonics is still classified as a theory, and so we want to kind of define what a theory is. A theory is a well-tested concept that explains a wide range of observations. So a lot of people want to throw around that word theory. I have a theory about this. I have a theory about that. There's a lot of evidence behind theories. So to say a theory is just untested is not true. It's a very tested idea that explains a lot and has a lot of evidence behind it. And so the theory of plate tectonics states that the pieces of Earth's lithosphere are in constant slow motion, driven by the convection currents in the mantle. And so everything we've been doing the past couple sections on seafloor spreading and subduction, and also going back to the idea of continental drift, all that evidence to support those ideas, is kind of leading up to the idea of plate tectonics, putting all those ideas together in that one theory of what's going on underneath our feet. And that's the theory of plate tectonics. And so what happens here, guys, is we have our continental crust and oceanic crust make up that layer known as the crust of the Earth. But also then if we add in the top part of the mantle, this makes up that lithosphere. So a lot of times we talk about the lithospheric plates. That's really all the solid rock there. The top of the mantle and the different type of crust make up our lithosphere. And so below that, actually floating on top of the asthenosphere, is the lithosphere. So below it is the asthenosphere. This is where the convection currents take place. And so we see here we have the plates. These are giant pieces of crust that are broken in different things called plates. And so we have the North American plate, we have the South American plate, pretty obviously named. Some are a little more obscure, so the Cocos plate or the Juan de Fuca plate, a little more obscure. But these are all the pieces of the crust broken in. You can see the boundary lines. And a lot of these boundary lines we've seen before, like where the mid-ocean ridge is, also happens to be that plate boundary. So also different subduction zones over here, different subduction zones off the coast, or over here off the coast of Japan. And what this creates are these different plate boundaries. So these plates, these broken parts of the Earth, they piece together to form these plate boundaries. And these plate boundaries are these giant places where we have major faults in the crust. And a fault is a break in the Earth's crust where rocks have slipped past each other and are still slipping past each other. And this creates three different major types of boundaries we're going to look at. The first type is a transform boundary. A transform boundary is where two plates slip past each other in opposite directions. And the most obvious example of this is in the western United States here on the coast of California, where the San Andreas Fault is. So San Andreas Fault line, you can see it here in red. And again, these plates are moving in opposite directions. So over here we have the Pacific plate and is moving to the north and to the west. And here we have the North American plate moving to the south and to the east. So these plates are moving in opposite directions, kind of grinding past each other. That'd be the transform boundary. Next, we have divergent boundaries. A divergent boundary is where two plates are moving apart or away from each other. And this is a great example is the mid-ocean ridge. Those two plates are moving away from each other in opposite directions. So here would be the idea of a mid-ocean ridge. Plates are going in opposite directions. Now, on land, a divergent boundary can form a rift valley. And this is actually happening in the eastern part of Africa. Along there you can see here's Ethiopia and Kenya. Two countries kind of occupy this area here. And there's a major plate boundary running right through here. And this ground is just being kind of pulled in opposite directions and it's creating these valleys. Eastern Rift Valley, there you can see it in the picture. And it creates these deep valleys as these crust is being pulled and thinned as it's being pulled apart. And our third type then is going to be a convergent boundary. So things are converging or coming together. And so here we have two plates colliding. And there's some major pieces we need to kind of put in on this. I didn't write it on the screen, but I'm going to say it, and I'd like you to put it in your notes also. So a couple things here. So what happens when different types of crust meet? Well, here, remember, oceanic basaltic crust is more dense than the continental granite. So when an oceanic plate meets a continental plate, that oceanic crust always going to sink down. When we have two continental crusts meeting, what's going to happen here? This would be like the Himalayan mountains would be a classic example. We have the Eurasian plate and that plate carrying India collided about 50 million years ago. And the denser one, whichever one is more dense, is going to subduct. So if you have two continental plates meeting, the more dense one will subduct. Same thing with two oceanic plates. Whichever one is more dense will subduct back down into the ocean, or down into the earth, where that may be. So, 8th grade, we're going to stop here.